I want to quickly take in a word from Dr. Sandip Chakrabarti as well. Dr. Sandip Chakrabarti, we're going to quickly give you an explainer, give our viewers an explainer on what those last few minutes could look like and what's going to happen when that soft landing eventually is witnessed, because the rover, once it comes out of the belly of the lander, is going to be a beautiful moment indeed, and there's so much lined up, at least if we talk about the 14 Earth days thereafter. Would you want to quickly comment on that, the journey that's going to be witnessed here in India? One lunar day equals to 14 Earth days, and those 14 days are going to be very crucial.
Yes. Okay. First, let me show you that this how we started. So this is the exact model of the propulsion module. You can see the thruster, which took us to the moon, and this is the lunar lander. We know that this lander has already separated from the thruster, and right now it is actually going around the moon in this position. Now in this position you can see there are 4 thrusters are there, and when it is going to land, all the 4 thrusters will be operating. Now you mentioned about the rover part. The rover part is, of course, once it lands, then the rover part, the ramp will open, and then the rover will of course come out. And as you can see that the rover itself has a solar cell which will operate, and it will do very good science. Now what science it will do? These are the 2 instruments which are on the rover. One is to find out the quality of the composition of the metal. You know, so there is a source of alpha particle in the X-ray. It will go onto the stones and the rocks, and that will be reflected back, and all these 6 detectors will detect them and analyze them and send the result to to ISRO headquarters by this antenna. Of course, this antenna will not come directly sent to ISRO. This antenna will communicate to the propulsion module or the orbiter 2, or if both of them fail, then they will also send it to ISRO, American Space Station. As you know that it has already been able to establish the contact with the space station. So ISRO has not taken any chance. The data will be received by us. Okay. This is the another instrument.
This is wonderful, Mr. Chakrabarti. You're really helping us understand as simply as it can get. Can you also tell us about, since you have that 3D model with you, what about the solar panels? How is it that the rover is going to essentially communicate with the lander, and how is it that the data finally is going to be sent back to the Earth? Can you tell us about the communication process as well?
Okay. So, yes, of course. So, first let me, just before that, maybe 30 seconds before what was happening, let me repeat it again, that this object, this lander will start from, this is a chart, this is the Chandrayaan 2, what Chandrayaan 2 did. Now we are going to do Chandrayaan 3, so the numbers have changed a little bit. Chandrayaan 2, they came out from 100 km to 6 km. Chandrayaan 3, it will come to 7.4 km. For 690 seconds, it will try to stop the velocity from 1.6 meter per second, 1.6 kilometers per second to 1.6 meter per second by the time it comes here. So this is 690 seconds. This is the place where it will be orienting. Just you were saying that it will orienting. It will test all its equipments. Camera will be put on, and it will start checking exactly whether the landing location is suitable. So next few seconds, merely couple of seconds, this is happening only 1 kilometer above the lunar surface.
That's the most challenging bit, isn't it? The last descent, the sudden right angle turn that the entire Chandrayaan 3 is going to take, and how that landing, of course, takes place, given the several challenges it's going to face in the last few minutes. Mr. Chakrabarti, many thanks. That really helped us understand the entire perspective better.